Okay, let's look at the homework 4.4, 4.5, problem number 6. All right, so we want to take the limit using L'Hopital's rule here. All right, so let's do that. Okay, so if you plug in x equals 1, so you have 0 on the bottom, so this is 0. And this is going to be 7, right? So this is going to infinity. So the this first term is going to go to infinity. So it could be negative, but it's infinity. And here, same deal. So as x goes to 1, natural log of 1 is 0. So you have a 7 over 0. So you have infinity. So you have an infinity minus infinity. So if you have infinity minus infinity, this is another case where you can do a L'Hopital's rule, right? So by combining these two, fractions together, we can get, all right? So you have a limit as x approaches 1, right? Then take the common denominator, which is just the product of the denominators. So it's a quantity x minus 1 times natural log of x, right? Then let's see, you have to multiply 7x by natural log of x. You're going to get the 7x natural log of x, right? Minus 7 times quantity x minus 1, right? Then we can just try to take the then see what happens. You can see that the denominator is going to go to definitely 1 minus 1, so that's going to go to 0. All right, so 1 minus 1, that's 0. So 1 natural log of 1 is 0. So the numerator goes to 0 as well. All right, now this is a situation for L'Hopital's rule, so we can just apply applying L'Hopital's rule. We get, so you still have the limit as x approaches 1. All right, so we have to take the derivative of the using a product rule. Derivative of the first is 1 times the second plus first x minus 1 times the derivative of the second, which is 1 over x, right? Then here you have to take the derivative of that. Let's see, so I'm going to pull out 7, so 7 out here, right? So you just have that. So the derivative of the first is going to be 1 times second natural log of x plus x times the derivative of natural log of x is 1 over x, right? And a 7 is factored out, so it's going to be derivative of that is going to be just a negative 1, right? Then try to simplify. So you have x cancel with x, right? 1 minus 1, so you can cancel that, right? So you have a natural log of x, right? So then we're going to let's see. Let's clean it up first. So this is going to be a 7 is just a constant. Put it outside, and you have a limit as x approaches 1. All right. Then you have natural log of 1, which is going to be 0, right? And here, oh, actually, maybe I shouldn't do that yet. You have a natural log of x, all right? Then you have a natural log of x plus, right, x times x cancel out, so it's 1, minus 1 over x, all right? Then if you plug in, what happens is natural log of 1 is 0, right? So this is 0. Then you have 1 minus 1 over 1, so that's 0. So everyone goes to 0, right? So we can use the L'Hopital's rules again. So let's apply that. So I'm going to go up here. Oops. I'm going to go up here, then apply the L'Hopital's rule. All right, so 7 is out here, and you have a limit as x approaches 1. All right, then derivative of a natural log of x is 1 over x. All right, derivative of natural log of x is 1 over x. All right, derivative of 1 is 0. All right, derivative of a negative 1 over x would be positive 1 over x squared. Right, then everyone goes to x goes to 1, so you will get, so this is going to be 1, and this is going to be 1 over 1, so it's 1, and this is going to be 1. Right, so this is going to be 1 over 2. Right, so this is going to be 7 times 1 over 2 is 7 halves. Right, so that's the limit. Right, let's type it in. All right, so answer was 7 halves. All right, so let's check the answer. All right, looks like we got this one correctly. All right, that's it. I hope that this was clear.